It's pretty likely in your exam or your test or however you're measured that you'll come across probability tables. And if you can do a Sudoku puzzle, you can do these puzzles. Think of them as puzzles. So you'll typically get a table like that and some questions related to that. But just remember that the probability of an event is going to be the number of favorable outcomes. That is the thing that you're actually looking for, divided by the total number of possible outcomes. Okay. There's a bit of a caveat there. We're presuming that all of the outcomes are all equally likely. For now, we'll just kind of go with it. It's a convenient myth. But we'll say, okay, so we know the number of possible outcomes, and we know the number of ways that those favourable outcomes can occur. So all probability is just a fraction. Remember, it's a number between 0 and 1. So all of these, whenever they want you to find the probability, always say, what am I looking for? What am I looking for over, divided by the number of ways that can have the possible outcomes that are open to us.
Everybody got that? Good!
The best way to do it is to illustrate with a point. So here we have fairly typical questions. So table below shows the results. Survey of 100 students. So go in and kind of pick out the numbers. 100 students in total, and their preferred pets. So what do we presume? Well, we presume that they have a preference. Dogs or cats. I couldn't tell you what I prefer actually. I've got a dog and a cat. But we'll say in this case you've got to make a choice. And I guess you've also got to say that there's only boys and girls. There's no grey area in this high school. Okay. So the columns are the preferred pets, and the totals are the totals of the rows and the columns. Okay, so 60 people preferred dogs regardless of whether they're boys or girls. The other 40 preferred cats, and it's a nice round number, 100, so these are already in percentages. So let's have a look. What is the probability that a randomly chosen student, whenever you see randomly chosen, you should be thinking, aha, we're going to be dealing with the total of all the students. So what is the probability that a randomly chosen student is a girl who prefers cats? Okay, so how many students are there in total? There's 100 students. How many of these are girls who prefer cats? Well, it's this one here, cats and girls. So it's going to be 24. So the answer is 24 over 100. We could rewrite that any number of ways, 0.24. We could express it as a percentage. However you want to do it, that's the correct answer. What is the probability? So this is B. What is the probability that a randomly chosen student prefers a dog? So randomly chosen student, so it's going to be out of 100 again, and we ignore the gender. So we don't care, as long as they prefer a dog, you're alright with us. And if you look, there are 60 of those people. So B, probability that they're just a dog person, is 60 people prefer dogs out of 100. And we could rewrite that as 0.6. We could rewrite it again if we wanted to as 60%. All three of those are equally fine. What is the probability that the randomly chosen student, again we get back to this, is a boy given that they prefer cats? Okay, so this is a conditional problem now. So we're only going to be talking about people in this column. So out of those 40 people, so that's going to be our denominator, how many of them are boys? Well, 16 of those 40 are going to be boys. So the probability that it's a boy, given that it's already, we've narrowed it down to being a cat person. Boy given cats, okay, as long as the marker knows what you mean. So there are 16 boys in that category and 40 people like cats. It's 9 out of 100 because we have this little proviso, given that they prefer cats, which means we ignore all of these dog people here. So 16 out of 40, I don't know what that would be as a decimal off the top of my head. 16 divided by 40. So, oh, okay, that's a nice round number, 0.4, which is 40%. Hopefully you can make sense of my doodles there. It may or may not surprise you to know that at school I was a giant nerd. And as much as I love my old friends from school, there was one thing that just drove me crazy. And that was Dungeons and Dragons.
You see, in role-playing, one person is a dungeon master or game master or keeper. He or she controls the world and tells the players what they're experiencing, whether it be battling with a coal monster or just kicking back in a smelly old tavern with some roguish elves. Played over a few hours, the game employs dice rolls to determine the outcome of certain events. Now, unlike most board games you might be familiar with, role-playing games often use a 20-sided dice.
Moz,
yeah,
I want to stop listening to this.
I completely understand.
Yeah. One thing that you notice with Dungeons and Dragons is a lot of it is dice. And I could never remember whether you use dice or die. Which one's the plural? Which one's I don't know. I still don't. I don't care. But let's have a look. So we have two standard 6-sided dice. Okay. And we want to complete a grid showing all possible outcomes, the ordered pairs. So the question is, how many possible outcomes are there? Well, first thing we need to ask is, are these independent? Okay. Are they independent? And the answer is, yeah, they are. They're independent. If you roll 2 dice, so you're playing a game of craps in a casino where you roll 2 6-sided dice, they are independent. The dice are not talking to each other, saying, I'm going to come up 5 this time, you should go 6 this time. They're not talking to each other. So there we go. There's no funny business going on here. How many sides does each side have? Well, the total number of outcomes on the first dice, N1, is 6. And the total number of outcomes on dice 2 is also 6. They're all equally likely, so we're fine with that. So the total outcomes, the total sample space, is going to be N1 times N2, which is 6 times 6. 36. So there's going to be 36 possible outcomes. All right. And it says here, complete a grid of all possible outcomes. So rather than make you do that, I'm just going to paste them in here. So here are all of the possible outcomes that are available to us. Just line that up. So this column here is the first dice. First die or first dice, I don't know. Don't leave a comment. The second dice is here, and the total of both of them is there. So that's our set of ordered pairs, and if you count them, there's 36 different combinations. Okay. What is the probability that the total of the two dice, I don't know, is 9? Okay. Well, the probability is going to be out of something. So its probability of getting a 9 is going to be something over 36, because there's 36 possible outcomes. Okay, so how many times can we get 9? So the number of times that we can get 9. Well, we have to count them. So 1 there, 1 there, 1 there, and 1 there. So there are 4 different ways of getting a 9. So the probability is 4 over 36, which is going to be what? 2 over 18, which is 1 in 9. 1 in 9 as a decimal. I don't know what that's going to be. Have a look. 1 divided by 9 is, okay, 0.0111111 forever and ever and ever. But we would say 0.111 repeated. Okay, next one. What is the probability that both dice show even numbers? And I'll do this one in red. So both of them show even numbers, so it can't be those. So 1, so 2 is that one there, that one there, that one there. These ones are all out because this is an odd number. This one here, this one here, there, that one there, that one there, and that one there. So the probability that both are even is going to be, again, something over 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 36, and I'm just going to leave it like that. So go back to playing Dungeons and Dragons. Here's another one. So every student must play a sport at Calculus High School. Below, above, really. Above is a table showing the most popular sports divided by gender. Okay, what are we presuming? We're presuming that none of the students play no sports, and that each student only has one preferred sport. We're going to count chess as a sport. Again, that was one thing at school that I didn't really mind it, but it wasn't really a big thing, but most of my friends played it. What is complete the table and answer the following. Okay, so we have to complete the table. So this column here in the totals is going to be the total of that plus that, and the totals along here on the rows is going to be the total of that row. So this one here is going to tell us how many total girls there are, how many total boys there are. And really it's just a Sudoku puzzle from here. Okay, well, let's work it out. So 102 plus 68 is 170. 170 there. It is really annoying that I cannot seem to get this Casio emulator to always be on top, so it's going to sort of disappear. And let's fill this out. 195 minus 114. It's going to give us 81. And I'm going to pause and fill this in. I'm sure you don't want to watch me putting in letters and numbers into a calculator. All right, welcome back. Let's do like a pretty quick test. Let's go across and see that our totals are correct. So 102 plus 114 plus 4 plus 24 plus 102 plus 12. Does that come to 358? Yes, it does. So that's correct. And let's go across. Let's just do this column here, this row there. So 170 plus 195 plus 102 plus 85 plus 180 plus 14. And I know I said I didn't want you to watch me just putting in numbers in a calculator, but it is a really, really important step. 746. Cool. Everything is above board. Now that we've filled in the table, what is the probability that a student chosen at random? So we see this little thing to really, really look out for. Chosen at random. So it's going to be out of 746 probably. Is a girl who plays either rugby or cricket. Okay, so girls who play rugby and cricket would be that and that. So, probability that it's a girl plays rugby or cricket is going to be something over 746. So how many are there? It's going to be 68 plus 81. 149. And I would probably leave it at that because the decimal is going to be some nasty number. So I just leave it as a proper fraction. Okay, what is the probability that a student chosen at random plays football? Okay, how many students play football? 180. We don't care whether they're boys or girls. So the probability that they play football is 180 over 746, and that probably simplifies. They're both even numbers, so it's going to simplify, but we don't really care. What is the possibility that a girl does not play netball? So I don't know why it's giving me the word possibility. It's really probability. Does not play netball. Okay, how many girls do not play netball? Well, how many girls do play netball is probably quicker. The 98 do play netball. That a girl. What is the probability that a girl does not play netball? So it's only out of the girls. So not netball and a girl. So how many girls are there? There are 388. Alphabet. And how many do not play netball? Well, we need to sort of do a bit of algebra there. So there's 388 minus the 98 who do play netball. $290. So 290 of the girls do not play netball. And that's our answer. Notice here that the girls have a lot more common sense than the boys. They don't play chess, apart from these two insane, crazy girls. And the world is right. This is pretty accurate. Most boys will not play netball. Most girls will not play chess.